So half past paper, week 3, all the odd numbers this week, and we've got 46 marks available, so slightly over half. So give yourself a little bit longer than half if you're trying to do it timed. Question number 1. Simplify m cubed times m to the power of 4. So m cubed means m times m times m. And m to the power of 4 means m times m times m times m. And if we are multiplying those together, then in total, we have m to the power of 7. So when we are timesing, we can add the powers. With the next one, I've got 5np cubed, and I'm cubing that number. So I'm timesing it by itself, and then timesing it by itself again. And that means that you can just do 5 times 5 times 5, or the 5 cubed, which is 125, n times n times n, which is n cubed, and then p cubed times p cubed times p cubed. And we know that when we're timesing, just as we did in part A, we're adding those powers. So that's p to the power of 9. For part C, 32 q to the power of 9 r to the power of 4 divided by 4q to the power of 3 r. So we're going to look at each bit in turn. So I'm going to start by thinking about the 32 divided by 4, and that's going to give me 8. Then I'm going to do q to the power of 9 divided by q to the power of 3. When you divide, we take away the powers. So q to the power of 9 divided by q to the power of 3 is q to the power of 6. And then with the last bit, r to the power of 4 divided by r, that is r cubed. Because that r on its own is the same as saying r to the power of 1. And again, we're dividing, so we're taking away the powers. Question number 3. The line L is shown on the grid. Find an equation for L. So the equation of any straight line is y equals mx plus c, where m is your gradient, the steepness of the line, and c is the y-intercept, which is where it crosses the y-axis. The y-axis is this one here. So firstly, let's have a look at the gradient. Gradient means for every one across, how much does this line go up or down? And here we can see it goes up, and it goes up by 3. For every one across, it goes up by 3. So we're going to make the gradient 3, y equals 3x. And then the value where it crosses the y-axis, which I've highlighted in yellow, this line crosses the y-axis at minus 6. So the equation of the line is y equals 3x minus 6. Another way you could have got the gradient is to make a triangle. Now, it doesn't matter how big you make your triangle. You just want to find some points that are quite easy to use. So that point there, that point there. And the gradient is given by rise over run. So change in y divided by change in x. That's 6 squares, that's 2 squares. And 6 divided by 2 also gives a gradient of 3. So you can do it a couple of different ways, but that's the equation of the line that we're looking for. Y equals 3x minus 6. Question number 5. Complete the table of values for y equals x squared minus x minus 6. Now this is a calculator paper, so you can do a table of values in your calculator if you have a fancy enough calculator, or I think the easiest thing to do is just to use brackets. So in your calculator, type bracket bracket squared minus bracket bracket minus 6, and don't hit equals just yet. You're then going to use that left-hand arrow and go back and put minus 2, that's the first x coordinate that we've got to check, in both of those brackets. So in your calculator, you're putting bracket bracket squared minus bracket bracket minus 6. And the reason I'm doing that is because it's just telling me to do that here. It's something squared minus that something minus 6, and that is how you get y. So bracket bracket squared minus bracket bracket, there's no number there, minus 6. So then I'm going to put minus 2 in both of those brackets, and doing that gives you 0. So that one there is 0. Now don't clear it, just use your left arrow again, go back and change both of the minus 2's to be minus 1. And by inputting minus 1, we hit equals, we get minus 4. I'm now going to go back, hit that left arrow, and I'm going to change them both to 1's in both the brackets. That gives me minus 6. Same thing again. I'm going to go back, change both the numbers in those brackets to be 2, and that is -4. And then last but not least, going back to both of those brackets and just changing them to be 3, and that gives us 0. We've now got 1, 2, 3, 4, 5, 6, 7 coordinates to plot on our graph. So -3, 6 is here, -2, 0 is here, -1, -4, 0, -6, 1, -6, 2, -4, and 3, 0. And then we're going to join that up with a nice smooth curve. Now make sure that when you get to those two values at the bottom, you might only have one value at the bottom, but if you've got two, then you want to make sure you dip slightly below in the middle. It wouldn't have a flat bottom, so something like that. There we go. And obviously if we'd have carried on, it would have gone up there, but we're not doing that. We've drawn exactly what they've asked us to do. It then says use your graph to find estimates of the solutions to the equation x squared minus x minus 6 equals -2. Well, x squared minus x minus 6 is what we've just drawn. We've just drawn y equals x squared minus x minus 6. So if I can draw y equals -2, then this is just simultaneous equations, just asking me when does this graph equal -2. So I'm going to draw the line y equals -2. It's not asking when it equals 0, so we're not doing the roots here. We're saying when does it equal -2. And that happens here and here. So I'm just going to look up from there and up to there and then state those two values. So I'm going to say that that's -1.6 for that one and 2.6 for that one. So x equals -1.6 or 2.6, positive 2.6. Well done if you got those. Question number 7. Enlarge shape A by scale factor a third, centre 0, 1. So scale factor a third actually means it's going to get 3 times smaller. We're making it a third as big, which makes it 3 times smaller. So this currently is 6 tall on this side. A third of 6 is 2. So my new shape is going to have a height of 2. And it's going to look a little bit like this, but that's in the wrong place at the minute, okay? What you need to do is work out where to draw it. Now, if you really didn't know, you're going to get 1 mark for drawing it correctly anywhere. So have a go at just drawing it somewhere if you're not sure. We're going to draw some lines on here. So I know it's coming from that point. So I can connect all of these up. And my new shape is going to be on those lines as well. Now, at the minute, to get from the centre to the bottom left-hand corner of this shape, it is 1, 2, 3 squares across and 1, 2, 3 squares up. However big that gap is, you need to enlarge that gap as well. In this case, we're enlarging it by making it a third as big. So now, instead of being 3 diagonal squares, 3 across and 3 up to get to the start of the shape, I'm going 1 across and 1 up. And my new shape has a bottom left-hand corner that goes there. We know it's 2 tall instead of 6 tall. I know instead of being 3 wide, it's going to be 1 wide. I know instead of being 3 tall here, it's going to be 1. And I know instead of being 3 diagonal squares across the middle of the squares, it's just going to be 1 diagonal square. And that's where my new enlarged shape is going to go. Question number 9. Jean invests £12,000 in an account paying compound interest for 2 years. In the first year, the rate of interest is X%. At the end of the first year, the value of Jean's investment is £12,336. In the second year, she gets an interest rate of X over 2, so half as much as she did in the first year. What's the value of Jean's investment at the end of 2 years? So she's putting £12,000 in the bank. She's timesing it by, now normally with compound interest, we times by, if it was 3%, we would times by 1.03. If it was 8%, we would times by 1.08 because that gets us 103% or 108% because remember interest is the amount on top. So it's an increase, that's why we've got that 1 point, whatever it is. Okay, so I know it's been times by some multiplier and we've got 12,336 at the end of that first year. So if I do 12,336 and I divide by 12,000, I should be able to get what that multiplier, what that number is. So 12,336 divided by 12,000 is 1.028. Now thinking back, I said if it was a 3% interest rate, we would times by 1.03. If it was a 5% interest rate, we would times by 1.05. So can you see here what that interest rate would be? And it's going to be 2.8%. So 2.8% is the interest rate. That is 100% of her money. Add an extra 2.8%, which equals 102.8%, which would be 1.028 as a decimal. Okay, so that's how we've got that number. It is 102.8%. If you times it by 100, you get 102.8. And so the extra, the interest, is 2.8. So X, we now know, is 2.8%. Now it says in the next year, she gets X over 2, which is going to be 1.4%. It's going to be half as much. So now in the second year, because it's compound interest, we're going to take the money she had at the end of the first year, 12,336, and we're going to times it by 1.014, because this time she's not getting 2.8%, she's only getting 1.4%. So if I do 100%, add on 1.4%, that is 101.4%, which as a decimal is 1.014, and that's where I'm getting that number from. Now, sometimes if it's to 3 years or 4 years or whatever, we put power there, we're just doing the second year. So it's just 1 year at this rate and 1 year at this rate. So I can just times by that, and 12,336 times 1.014 is £12,508.704, but because this is money, I'm going to round it to 2 decimal places. That 4 rounds down. So the value of Jean's investment at the end of 2 years is £12,508.70. Question number 11. F and G are functions such that f of x equals 2 over x squared and g of x equals 4x cubed. Find f of minus 5. So all this means, if we're saying f of x, x is our input, whatever number is here, that's what we're putting into this function. F is just the function. G is just a different function with an input of x. So whatever number goes in this bracket, that's what you're putting into the function. And then on this side, that's just the instructions of what we need to do. So if we look at g of x, for example, g of x is just the title. Think of it like that, the name of the function. X is what we're putting in, because that's what's in the bracket. We're going to cube it, and then we're going to times it by 4, and that will get us the output. Okay, so that's what that function does. So if we're asked for f of minus 5, it just means put minus 5 into the function that is f. So we're going to take minus 5 and pop it here where the x is. So instead of f of x, we're doing f of minus 5. And that means we're doing 2 over minus 5 squared, which is 2 over 25. Can't simplify that. You could write it as a decimal if you wanted to, but they've not told us how to write it. So either 2 over 25 or 0.08, either of those answers would be absolutely fine on the answer line. And then we have f of g of 1. Now this is called a composite function. It means you're going to put 1 into g, and then whatever your answer is, you're going to put into f. So let's start by putting 1 into g. G of 1 is 4 lots of 1 cubed. 1 cubed means 1 times 1 times 1, and then we'll times that by 4, so that is 4. So we know that g of 1 is 4. We're then going to take that 4 and put it into f. So you're always working from the inside out. 1 into g, that answer into f. So f of 4 is then 2 over 4 squared, which is 2 over 16, which is 1 over 8. And that would be your final answer for that one. 2 over 16 would be fine. It didn't say you had to simplify it, so you're all good. Question number 13. A, B, C and D are points on the circumference of a circle centre O. FDE is a tangent to the circle, show that y minus x is 90. You must give a reason for each stage you're working. So circle theorems is this topic, bit tricky. And there's a couple of circle theorems I'm going to use here. Okay, so a tangent, remember, is that line that just touches the edge of the circle. And whenever you have a circle on a tangent and you have a triangle inside, I like to remember it, triangle on its tip on the tangent, then whatever angle is here is equal to this angle here, and whatever angle is here is equal to this angle here. And that's called the alternate segment theorem. Alternate segment theorem. So I therefore know that if, let's look at this triangle here, this triangle is on its tip, balanced on the tangent. So I therefore know that whatever this angle is here, all the way over to there, is going to be y, because I've got y up here as well, and that's using the alternate segment theorem. So the first thing I'm going to write is angle BDE, which is the one that goes from B to D to E, so round that angle that I'm talking about, equals y, and that's because of the alternate segment theorem. So that's the first thing I'm going to do. The next thing I'm going to do is say that angle ODE equals 90 degrees because a radius and a tangent meet at 90 degrees. So whenever you have a radius going from the middle of a circle and it's touching a tangent, they're always going to make a right angle. So I therefore know that the entire angle is y, this bit is 90 and this bit is x. So therefore x add 90 equals y, or y take away x equals 90. So I'm just going to put therefore y take away x equals 90 degrees. I think there's a few different ways you could do that one, but that seems like the easiest way to me. Dylan was asked to give some possible values for x and y. He said y could be 200 and x could be 110 because 200 take away 110 is 90. So he's absolutely right. 200 take away 110 is 90. But y does not equal 200 as it is an angle in a triangle. And angles in a triangle add up to 180 degrees in total. So that's way too big, isn't it? You're already over the total. So can't happen. Okay, question number 15. A darts team is going to play a match on Saturday and on Sunday. The probability that the team will win on Saturday is 0.45. So therefore, we know with these branches, they always add up to 1. If the probability of winning is 0.45, then the probability of not winning is 0.55. If they win on Saturday, which means we've come up this branch here, the probability they'll win on Sunday is 0.67. Great. But if they do not win on Saturday, so if we're going down this pathway, then the probability of them winning on Sunday is 0.35. Okay, so we've got two different scenarios. So this is conditional probability. It depends on what happens on Saturday as to what happens on Sunday. So these events are dependent on each other. Now again, the branches have to add up to make 1. So if you've got 0.67 for Sunday, then you've got 0.33 for not winning, because those two have to add up to make 1. And same down here, if you've got 0.35 for winning, then it would be 0.65 for not winning. So each branch needs to add up to make 1. And that's that, 2 marks. Find the probability that the team will win exactly one of the 2 matches. Well, how could that happen? Either we could win on Saturday and then not win on Sunday. That would be one scenario. Or we could not win on Saturday and win on Sunday. In both of those situations, they've won exactly one of the 2 matches. Now, with probability trees, we times along the branches and then we add up the options that we want. So I want to do 0.45 times 0.33 for the blue probability there, and then 0.55 times 0.35 for the yellow route there. And I'm going to type both of those in my calculator because this is a calculator paper. So that is 0.1485. And 0.55 times 0.35 is, oh, press the wrong button. 0.55 times 0.35 is 0.1925. I'm then just going to add both of those together. So 0.1485 add 0.1925, and that is 0.341. That's my probability of winning exactly one of the two matches. Great, question number 17, and we have a histogram. The histogram shows information about the times taken by some students to finish a puzzle. Complete the frequency table for this information. So the most important thing to know about a histogram is that because the bars are different widths, it is the area of the bar that gives you the frequency. So to get the area of the bar, it's just a rectangle, we're just doing base times height. So for this first bar, it has a width, a base of 5, and a height of 0.8. So I'm going to do 5 times 0.8, which gives me an area of 4. So the frequency of that bar is 4, which matches up with here, so I'm happy with that. For the next bar, I'm going from 5 to 15. So this bar has a width of 10 and a height of 0.4, which is also 4. So those two bars actually have the same area. For the next one, it has a width of 10 and a height of 0.6. So that one has a frequency of 6. I could be putting these in, 4 and 6. For the next one, we have a width of 5 and a height of 1. 5 times 1 is 5. So there's 5, what are we talking about? 5 students in that category. And then for the last one, it's 20 wide and it is 0.2 tall. So 20 times 0.2 is 4. So that one is also 4 as well. So we filled that out. And then it says find an estimate for the lower quartile of the times taken to finish the puzzle. Now the median would be in the middle. The median is in the middle. So if I said find an estimate for the median, we'd have to try and work out how long that middle person took. But for the lower quartile, we actually want to go a quarter of the way through the data. So a lower quartile is 25% or a quarter through the data. Now to find that person, we're going to add 1 and divide by 4. Adding 1, you always have to do, and then just divide by 4, and that's going to tell you a quarter of the way through. If I had 5 people, for example, the middle person is the third. So we add 1 and divide by 2. 2.5 is here, so that's not very helpful for the middle when we're ordering things. So if I want the lower quartile, I'm going to add 1 and divide by 4. There are 4, 8, 14, 19, 23 people. So if I add 1, that's 24, divided by 4, which means the 6th person is a quarter of the way through. So where is the 6th person? Well, the first 4 people are in this category. And so the 6th person is in the middle of this category. They're the second person into that category. So what we're going to do is go this category and we're going to go halfway through it. And that means that we are looking here, bang in the middle of that category. So if the category goes from 5 minutes to 15, we're going to say that that person took 10 seconds, and that's going to be our guess for the lower quartile. Or 10 minutes, sorry, I didn't realise it was in minutes. There we go, quite tricky that. I've only really seen that come up very rarely, so hopefully that makes some sense, and don't worry if it doesn't. Question number 19. Shape S is 1/4 of a solid sphere, centre O. The volume of S is 576 pi centimetres cubed. Find the surface area of S. Give your answer correct to 3 significant figures. So we're given all the formula that we need up here. We know that the volume of this shape is 576 pi. However, that shape is only 1/4 of a sphere. So imagine our shape like this. Ooh, how can I draw that? There you go. If that shape was an entire sphere, we would need to times it by 4. So I'm going to take 576 pi and I'm going to times it by 4. 576 pi times by 4. And that would be the volume if it were a whole sphere. rather than being chopped in 4, and that is 2,304 pi. Now that would be equal to 4/3 pi r cubed. So I'm going to say that the volume of the sphere, the whole sphere, is 4/3 times pi times the radius cubed, and it would equal 2,304 pi. And now we're going to go ahead and solve this to try and work out what the radius is. So I'm going to start by dividing both sides by pi to get rid of that. I'm then going to multiply by 3 to get rid of this fraction part. So that means that 4r cubed equals 2,304 times 3, which is 6,912. I'm then going to divide that by 4. So I know that r cubed is 1,728. Now the opposite of cubing something is to do the cube root. So I'm going to press Shift and then the square root button. If you press Shift square root, you get the cube root on my calculator anyway. 1728, and that is 12. So the cube root of 1728 is 12. So we now know that the radius of this shape from the middle to the edge is 12. I now need to work out the surface area. But again, I need to think about the fact this isn't a whole sphere, it's only a quarter of a sphere. So with the surface area, I'm going to do 4 pi r squared, but I'm then going to divide it by 4. So 4 times pi times 12 squared. 4 times pi times 12 squared gives me 576 pi. And again, I'm just going to leave it in terms of pi because it's easier. But that would be the whole sphere, the whole surface area, the area of the outside of the whole sphere. I only want a quarter of a sphere, so I'm going to divide that by 4. 144 pi. Now that takes care of the curved part, this part on the outside here, but I've also got a semicircle flat bit here and a semicircle flat bit here to get the total surface area. So those two semicircles put together would make a whole circle of radius r. So I'm then going to add on pi r squared. And remember that radius is 12, so pi times 12 squared, which gives me an answer of 288 pi. Now I can go ahead and press that SD button or the format button and get that in terms of, not in terms of pi, so 904.778 and so on. They want it to 3 significant figures, so your answer is 905. Next question. Last question, I think. Question 21. Jackson is trying to find the density in grams per centimetres cubed of a block of wood. So as soon as I see that word density, I'm going to remember my formula triangle, density, mass, volume. Okay. He measures the length as 13.2, correct to the nearest millimetres. Okay, so immediately, we haven't seen the word yet, but as soon as they say correct to the nearest, this is a bounds question. So that means if it's been rounded to the nearest millimetre, 0.2 of a centimetre, that's the millimetre column. So I'm going to do 5 above and 5 below, or in this case, it would be 0.05 above and 0.05 below. If you've rounded to the nearest 0.1, you divide that by 2 and you put half of it above and half of it below. So 0.05 above and 0.05 below to get the biggest and the smallest it could have been before you rounded it. So for the length, it could have been 13.25 or it could have been as low as 13.15. Same thing again with the next one, 16.0, we've rounded to nearest millimetre. So the width is going to be 16.05 and 15.95. And then the height is going to be 21.75 and 21.65. Luckily for us, they were all the same. The mass is 1,970 grams, correct to the nearest 5. Now, if we've rounded to the nearest 5, again, we divide that by 2, and it's going to be 2.5 above and 2.5 below. So 1972.5 and 1967.5. So now I've got all my bounds. These are the numbers that we'll be using rather than the original numbers that they gave us, okay? Now it says, by considering bounds, work out the density of the wood. They're not asking me for the upper bound. They're not saying what's the biggest it could be. They're not asking me for the lower bound. They're not asking me the smallest it could be. They're asking me to consider bounds. And considering bounds means we need to do the absolute biggest. We need to do the upper bound and the absolute smallest, the lower bound. And then we're going to compare them both. So for the upper bound, the sum that I'm going to do to work out the density is mass divided by volume. Now, if you want the biggest answer possible, you want to use the biggest mass, but you want to share it by as few things as possible. You want to share it by as small a number as possible, and that's going to make your answer even bigger. So we're going to do mass divided by volume. We're going to use the biggest mass and the smallest volume. And then for the lower bound, I'm going to do the smallest mass divided by the biggest volume. Now remember, volume comes from length times width times height. So for the upper bound, I'm going to do 13.15 times 15.95 times 21.65. I'm using all of the lowest ones because I want this volume to be as small as possible. 13.15 times 15.95 times 21.65 gives me an answer of 4,540.925125. I'm not going to round anything, not yet anyway. And then for the other calculation, for the lower bound, I need to get the biggest volume that I can. So I'm going to do 13.25 times 16.05 times 21.75. So timesing those together, I get 4,625.409375. Great. I now need to, for the upper bound, do the biggest mass divided by that answer. So that's going to be 1,972.5 divided by 4,540.925, so on. And for this one, I'm going to use the smallest volume, 1,967.5 divided by this number, 4,625.409375. Right, I'm going to do this one on the right first because I've got that number in my calculator. So 1967.5 divided by that answer gives me 0.425367775. And you'll notice I'm putting a lot of decimal points here. I'm not rounding anything yet. And for the upper bound on the left, 1,972.5 divided by 4,540.925125 gives me 0.4343828, and so on. Okay, so now it says by considering bounds, and to do that we need to see how many significant figures they agree to. So if I rounded both of these numbers to one significant figure, they would both be 0.4. Great. Now let's see if we can go to two significant figures. Two significant figures, this number would round to 0.43 because the next numbers are 4, which rounds down. And this number would round to 0.43 because the next numbers are 5, which rounds up. If you tried to go to three significant figures, then these numbers are going to be different. So we have to say our answer is 0.43 because both bounds agree. Both bounds agree to two significant figures. And we have to write that reason to get 5 marks for that question. Very, very difficult, very much grade 9. Hopefully that made some sense. If not, leave me a question in the comments and I will try and get back to you. I hope you found it helpful and I look forward to seeing you next week.